Welcome to our talk, How Good of a Developer Are You? And I think it's really cool that I get the opportunity to get here on stage. I've been in the NL board for a couple of years, and then you don't get the opportunity to submit a talk. So I've been out of the board for a few years, and I actually got through the program committee, so it's quite exciting. It's also pretty cool that we can say we are Roy. So
we are Roy from Open Value.
Yeah. So who am I? I'm a co-founder of Open Value. I've been in the IT industry basically my entire career. Worked at the large IT services provider, at the smaller one, and I've been hiring in all these different positions that I've had throughout the years. And I have quite some ideas about how to determine if somebody is a good developer. And how about you, Roy?
Same. Basically the same. I'm running the Rotterdam branch of Open Value, and I'm also looking for good developers. So we need to know what a good developer actually is, and that's the main topic of today.
All right. So I hope you all got the opportunity to scan the QR code here, because we want to use the information a bit later on. This is who we are.
We are Roy.
We are Roy. So how to determine if somebody is a good developer? I think there are quite some, practices out there, and especially like, a couple of years ago, I think it was pretty common to ask people if they know acronyms such as DRY, YACNI, H2S, anyone? Hypermedia, as the engine of state, solid, and so on. You know, it's maybe important that you know these things, but does it say anything about your actual development skills? And there are also people who think it's quite important that you know these things that you learned during computer science classes and how to solve binary tree search algorithms. So let me ask you, when did you apply this the last time in your project? Then you can also go to the internet and just look up the most commonly asked interview questions, and better hope that the interviewee didn't also went to the same website and read the answers there. So maybe also not a great idea. Then there's this trend of open hiring, which is, actually quite exciting.
Has anybody used open hiring? No hands. So you need to explain what it is.
Sure. So everybody has biases. And some biases you're aware of, and some you're not aware of. And if you do an interview, you're applying also those biases you're not aware of. And if you want to prevent that, there's a solution for that, and that's open hiring. You just put out a job posting there, and anyone can apply, and they can just start if they would like to. And after like 2 or 3 weeks, you evaluate how it's going from both sides, and you decide if you want to continue or not. So that's an interesting approach, right? Not 100% sure if that's a good approach for software engineering, though. And of course, there are a ton of proxy variables that give like an indication if you have been a good developer, like your CV, references from people you work with, prior experiences, questionnaires that you did around the topic of engineering, education, and so on. There is whiteboard coding. A little bit tricky because, maybe you're used to having an IDE around, and also there's a lot of pressure if people are watching you while you write code on the blackboard. And there's the lengthy assignments, especially if you're in consultancy, then this is actually quite annoying. If you're looking for a new project, you maybe do like 3 or 4 different intakes, and if you're unlucky, you need to make 3 or 4 assignments that can cost you 1 day, 2 days, or 3 days. And it oftentimes also happens that these assignments are out there on GitHub, and you can find the solutions there as well, especially with one of the largest banks in the Netherlands. I know this is the case. So yeah, maybe it's also not that perfect. So I think it's maybe interesting now to have a look at the outcome of the survey, right?
Let's look.
So let me see. You know where to look, I think.
If you can put it on present. There it is. Big.
Oh, it's quite a lot.
That's quite a lot, 150. Thanks. So, let's see. "3% is not a good developer. 2% not a developer at all. Leave. But it's about 50-50. Like most people think they are a good developer or maybe. What did you base that on? Just shout. What did you base it on? Based on? Believe in yourself. Gut feeling. That's good.
Oh.
Your HackerRank score. That's a good one. OK, let's look at the next one. So, wow, again, almost 50-50. That means that there are like 72 or 73 JCP or OCP certified people here. Can we show hands? Who has the JCP? Nice. Who has 6 or below?
Ah, quite a few.
Nice. 7? Not 8? 11? Some. 17? 1? OK, so some of you have this certificate. Who liked the process? Can you? I kind of knew that was coming. OK, so why? Why don't we like this process? What's wrong with it? Exactly, exactly. It's purely knowledge-based. It's a compiler exam. It teaches you how to be a compiler. And we all use an IDE, so why? Doesn't make sense. So again, science degree, computer science. Most people here, bachelors in computer science. But you also see like 17%, 13% have other educations, which is pretty good. And there's also 15% none of the above. That's cool. So it's a pretty diverse group. But still, most have their bachelor or HBO in Dutch. But do we think it actually matters? 61% thinks a bit. So it is important, but it's not the most important thing. Only 12% think it's actually important to have a computer science degree, which is low, I guess. Why did we go? Why did I go there? Why did I put in all this work if it was really unnecessary? Oh, well. A senior developer. What makes a senior developer? He or she has to have other skills. What kind of skills? Coaching. So you can't be a senior if you don't coach. Communication, yeah, that's important. Does years of experience matter? It helps. OK? OK. Interesting, interesting. Let's look at the last one, the word cloud. So these are all words you use during hiring process. So experience, code, skills, interview, attitude, passion, salary. OK, makes sense. Programming, mindset. It's pretty spread out. There's a lot of things there, but most of them, sweet. Most of them make sense, right? We want somebody to code and have skills. And yeah, that's basically the gist of the talk. So let's hand it back to you. Because
so those are some really nice insights. And we're going to come back to a few of those questions later on in the presentation. And I needed to laugh a little bit that a couple of people said you need to be 40 to be a senior developer. So we're both older than 40. So
I turned 40 this year, so I'm a senior developer, finally.
Yeah, yeah. That's the reason it was there.
If I have other skills.
Yeah. But did you answer that yourself, maybe? Oh, OK. All right, so maybe it's also interesting to have a look at what other companies do, like Google, for instance. I mean, they're known to have a quite extensive hiring process. And if you go to their website, you can actually find out what the process looks like. And they start off with an online assessment, like some coding quiz questionnaires that you need to fill out. Then there's some short virtual chats with people you could be a peer with in the future, hiring managers, and so on. And then if you get through that round, you get to do some project work, complete a small project. So that's going to cost you a couple of days, probably. Maybe you also need to put in some stuff in writing and deliver some additional materials there. So a lot of work again. And then you get to the actual interview rounds, and there are 3 or 4 in-depth interviews. So you can basically say that Google does everything that was on the previous slide. So there's probably some stuff in the process there what works, but who knows what actually works of all those things. And maybe it's also interesting to have a look at research about hiring good developers, or about research targeted at determining how you can predict developer productivity, and so on. And that's what I did, and I want to share some insights around this, so you can maybe also use this in your own hiring practices. So first, there are aptitude tests. So an aptitude test is like an online questionnaire with puzzles, IQ-like quizzes, puzzles that you need to solve. And the idea is that these tests have a predictive power in how you're going to perform around certain competences. And it was quite popular in the 70s. And it turns also out that there's some research showing that it doesn't really work. There's actually a large study done with over 3,000 students. They were asked to do a specialized programming test targeted at measuring if somebody's a good fit for a development role. And part of the students are also given a test that was being used at the United States Air Force. That was a generalized aptitude test. And afterwards, the performance of the students was tracked to see which test had better predictive power. It turned out that was about the same for both tests. And it also turns out the predictive power is negligible. Okay, so...
Is there anybody that uses the aptitude test in their current hiring process? That's good, nobody.
I see no hands. So when I started my career, actually, I needed to do an aptitude test for a large IT services provider. And the story goes that if you had a really high score on the test, you would get an offer as a software developer. But if you scored a bit lower, you would get an offer as a test engineer. I always like to think this is true. Okay, education. What's the role of education? So you could see in the survey there were some, different ideas about the importance of having a computer science degree, or at least there were people with a computer science degree and without, from different ranks. And I used to think that it's quite important to have a proper background and understand how stuff works under the hood. And when I got to hire the first people, I thought they need to have a computer science degree. But then I got more years of experience, and I worked with a lot of really great people, and a lot of them did not have such a computer science degree, or some didn't even have an education at all. And I changed my mind, because I saw in practice that people can be really good without a computer science degree. And this is also what was found in a meta-study by Roth. And there was a correlation there of 0.16 between performance on the job and the relationship with the proper education. 0.16 is really weak. 1 is a perfect correlation, where it has perfect predictive power, the right kind of background in education and job performance. So 0.16 says it does not matter that much. There is, however, one thing there, that in the first year or 2 after graduation, there's a higher correlation of 0.23. And I think this is something that we maybe also intuitively would feel that this is the thing that we expect. So education, it has some predictive power, but after the first few years, not that much. So if you put out a job posting for a senior, you don't really need to ask for a computer science degree, right?
So after 5-6 years, it's no longer relevant.
It's no longer relevant.
Experience is more important.
Is it? Well, surely you need to be experienced to be good at something. But how much experience do you actually need? Well, the funny thing is that people actually studied this, and there's a positive effect of having programming experience if you want to hire, really performant developers. But other studies showed that beyond the first few years, again, having more experience doesn't matter a lot, but the first few years are important. And again, how many job postings do you see? We're looking for a senior developer, 3 years of experience without a computer science degree. I don't think a lot of people would expect that person to be a senior developer. And this might be one of the biases that we have, right? Because think about it. How oftentimes have you seen a really good developer that had only like 2 or 3 years of experience and was contributing a ton to your project? So think about that. Then surely knowledge is important, right? So there was a question in the survey about Java certification. Well, the one that Oracle presents you indeed challenge you to think like a compiler. Well, you actually have a compiler on your laptop, so maybe it doesn't make a lot of sense to completely being able to reproduce that. It is, however, the case that according to Chi, that having the right knowledge in a certain expertise, knowing all the facts and knowing that things work in a certain way, is a really good predictor for performance. So this is of course worth something if you want to find out if somebody is a good developer. Do they have the right knowledge? But it's merely a predictor. And knowing how to develop is more important than knowing that certain things in the Java language are as they are. So we actually want to find out if somebody knows how to build software. And we want to know if somebody is skilled. And what is skill actually? Well, Ferguson says it's an ability, it's a trait, it's something that an individual can do, like winking your eye. It's an ability. But it's an ability, well, you cannot really improve on. You can either wink or you cannot wink. And skill is a special type of ability. You can improve it by practice, just like you can improve your programming skills. So how to determine what the skill level is of a developer? There's a model from Drivers and Drivers that I actually got to use in my graduation assignment a long time ago. And this model describes the different skill levels you can easily name. And it goes from novice to master. And to explain this model, I would like to make an analogy with learning how to drive a car. So the first time you step into a car, and you haven't never driven it before, somebody will need to explain to you how to operate it, how to put down the clutch where it is, how to shift gears in which order, where the steering wheel is, the gas pedal, and so on. And you try to memorize all these things. And it's well, really tough, and you keep forgetting exactly what the order was with the shifts. But at a certain point in time, you succeed, and you go on to the next level. You become competent, and you try to remember the processes, that you let go of the clutch easily, in a gentle way, put down the gas pedal, and, well, you could become better at it, but it's costing you a lot of mental energy. You need to actively think about what you're doing. And as you practice more and more, you progress to the next stage, you're proficient. So basically all the procedures that you need to drive in the car, brake on time, if you are going towards a crossroad, it's coming to you in a more natural way. But if you drive through a busy city center, you're probably quite exhausted after a while. But if you drive enough, you can become an expert, and you don't need to actively think about all these things that you need to do while you're driving. And a lot of people reach this level. You can drive the car even if it's relatively busy. You can talk to the person next to you and have a good conversation. So you're no longer really mentally engaged with the actual driving. And some people can become a master at something. Max Verstappen, of course, but maybe also that uncle of yours that is really good in driving his car. He's really into it, and he can drive really fast into his garage, stop the car just in time with 2 millimeters before the wall, and he can basically operate the car as if it was a part of his body. And people who are able to do a practice like that, they become a master. And I think that some programmers can also relate to this when they experience a state of flow. If you're experiencing a state of flow, you're no longer actively thinking about which keys to put down on your keyboard, which language constructs to use. You're just solving a problem, and you're not even aware really of the IDE you're working on. And the problems are just being put out there, and you're forgetting time, and before you know it, you have great working software, and you're really productive. So that's the kind of developer that you want to be maybe, or maybe also want to have in your team. So is it then all about skill? Well, skill is not, having people with skill is not the same as having people who are performant. There are more things to it than that. And it turns out, according to well-known research from Campbell, that there are 8 major components that are part of job performance. And there are 3 really important of those. That is, of course, skill, knowledge, we talked about that. It's a good predictor. And of course, motivation. If you don't like to do a job, you're probably not going to do it well, even though you're highly skilled. So these are the other ones. And what Campbell also said is, while these 8 different dimensions are all important if you want to know if somebody is going to do a good job in a certain field, some of these dimensions are more important for certain job types. And McGill looked into this, and McGill determined that for a developer, technical skill is the most important one. So it is about skill still. It's very, very important. This is also what empirical research showed. Jurgensen, he did an interesting exercise. He studied almost 5 million bids that were done on a marketplace where clients can put out projects. And what he did, he analyzed the service providers that won the bids, and he checked how they did those projects. And he found out that low price providers with also lower skill, that those providers would fail more often in projects than the other ones. Almost 10% higher failure rate. Again, skill is the best predictor of how well a software development project is going to be executed, and also how good a developer is going to do his or her job. So what about teamwork then? Surely you can be a really skilled developer, but if you cannot work well with others, it's not going to end well. Well, yeah, it's quite difficult to say something, well, research-based about team performance, according to Baker and Salas and Vollmer. But, you know, Land, Wong, and Jeffrey, they found out that even in a team, individual skill is the central component determining how good the team will perform. Okay, so skills are really, really important also in teams. And you know, the fun thing is, in a team, developers are really important. We already knew that, of course, but the nice thing is there are a couple of papers that say something about this. There's a couple of studies that show that the difference in programming skill was the best predictor of project success. And also interesting that some of these studies said it doesn't matter that much which technology stack you're using. It's more about the quality of the developers that you have. So we like, of course, to believe that Java is going to be make us far more productive. Well, there might be some truth to this, but it's more important that you have the right developers as your colleague. Then there's the book from Boehm, from 1981. It's a famous book, and well, he goes to great lengths to describe that the people factor is the most important factor that determines the success of a project, and that developer attributes are the most important ones. So developers are really important, and we want to have those skilled developers. Developers. You know that one? Developers. Steve Ballmer, right? Okay, so maybe this is also a bit common sense. The US Bureau of Labor Statistics has a definition of a software developer, and they say it's someone who usually holds a bachelor degree in computer science, well, usually, and has strong computer programming skills. So they knew this all along. So what we need to do is hire based on skill level. If only we had an objective way to measure those skills. So there comes Gunnar Bergersen. with whom I've had the pleasure to spend some time, also a few weeks ago, and he did a PhD study at the Oslo University. He is currently an associate professor there, and he dedicated basically his career in measuring programming skill in an objective way, and he's using Java for it. So this is quite interesting, right, when I first heard about this. So Gunnar, if you look him up at Google Scholar, he wrote a bunch of papers and also investigated other things like the effectiveness of daily stand-ups. Quite funny that somebody actually looked at that. And he wrote a couple of papers about measuring programming skill. And what he wanted to do is somehow create a system in which he could test his hypothesis on how to measure skill level of developers. And that's what all these papers are about. So we already talked a little bit about how to measure skill. We talked about the homework assignment, the whiteboard coding, the online questionnaires. So online questionnaires are maybe a nice way, but most oftentimes these questionnaires don't really resemble the actual working conditions. What's quite important, you want to work in your normal IDE, working on tasks that you can encounter while you're doing actual projects, like writing unit tests, and maybe not doing the binary tree search algorithm. And who determines what good items are for those questionnaires and what good whiteboard coding assignments are? That's quite subjective. And you do want to get it right, because measuring skill level is, as we learned, the most important thing if you want to know if somebody's going to be productive. One of the things Gunnar could use is the Dunning-Kruger effect. So the Dunning-Kruger effect goes basically like this. If you ask somebody how well they think they will perform in a specific field, like the first question of our survey, you ask somebody, do you think you're a good developer? Then most people tend to overrate themselves. They score themselves too high. Unless they are really good, like the master or expert level, then they tend to score themselves a bit too low. But the funny thing is, if you ask the same person and you say, how good do you think your peers say you are, then they tend to be far more realistic. So this is something, an insight that Gunnar could use, because this was proven in a nice way by Kruger and Dunning.
One of the things he used for calibration. So in his system, he calibrated all the tasks you can make. And one of the questions for calibration is, how do your colleagues, what kind of skill level do they think you have? Are you a junior developer, medium developer, senior developer? Yep.
Yes, and so he went on and looked at more research about understanding how to measure skill. And it turns out in the 50s, people were already trying to understand who was a good punch card operator. And this type of research went on in the 60s, 70s, 80s. And in the end, Gunnar looked at more than 20 different studies about job performance, most of them related to software development. And almost all of these frameworks that he ran into mentioned that if you want to understand skill level, look at specific representative tasks that look like the thing that you would normally do while doing the job, and by using the tools that you also normally use. There's one nice meta-study here on the slide from Linda Koopmans et al. That makes a nice summary of a bunch of these studies, if you're interested. And Gunnar thought, okay, now I need to understand which tasks I need to create for my goal of building a system to measure the skill level of developers. There's a study with Lisp programmers from 1985 that wanted to find out how they can predict if somebody's going to be a good Lisp developer. And Lisp is especially interesting for this. You have like 25 different ways to solve a problem in Lisp. Apparently, I'm definitely not a Lisp expert. And what the researchers found, that if you're good in solving problem 1, 2, and 3, it has high predictive power on how you're going to solve other types of problems. So now, with this insight, Gunnar realized I need to find the same type of tasks for Java, and maybe I can reuse some of the Lisp tasks. And since he wanted to build a system out of it, he also wanted to have a way to determine the quality of a solution to a programming task. So he did some own research there. And he also added a dimension, time, because if you want to measure skill level, it's nice that you can do it in a timely fashion. And if people take a lot of time, it also says something about their competence level. So now he had all the right ideas in place, but he still needed to have like a model and some data that he could use to do some actual measurements. He used the Rush model. And the Rush model is a model that has been around for a long time. And it was originally created to measure reading performance of students. And it is being used in all kinds of systems that want to measure psychological traits. OK, what Gunnar now did, he had this model in place. He had an idea how to create tasks, and he used some of the list tasks. He created some additional tasks with the help of experts. And then he reanalyzed the tasks to also let it work with the insights that he created himself around time and quality. And now he actually got a grant that enabled him to hire all kinds of developers from the field, from different countries, over 250 different developers. And these developers were initially ranked by using the Dunning-Kruger effect and by some other means as well. And he asked those developers to do the different tasks so he could bootstrap the model and see what makes someone a senior developer according to the model after medium, junior, or even higher. And we would like to show you this system, and that's something that Roy is going to do.
Exactly.
So I
was not just there for the good looks.
For you, and go ahead.
Let's see if it works. So, it works. Initially at OpenValue, we tried some other systems to evaluate our developers, and eventually we ended up using DevSkiller, which is an online platform. And you get like knowledge-based questions, and some kind of coding questions, multiple choice. It was okay. Wasn't perfect, but it was okay. And then we met this Gunnar dude from Norway. He had this amazing theory about testing developers, and he has this this product which he created together with some students to measure. And we started using this, and I'd like to show you what it looks like. So let's do a demo. We've got two perspectives here. You got the perspective of the candidate who's taking the test, and there's obviously the perspective from Grabs and the company like us. So the first thing is that we create a URL which is completely anonymized with a random username, and we send that to the candidate. They open this up, and dikke fingers. Yes. So we open up the URL, and then you get to pick a password, obviously. And it's also locating the nearest VPC for performance reasons. And when you're done, you can press Next. Then it downloads a file for you, so you don't forget your username. And then you can start a virtual machine. And this is all done from the browser using Apache Guacamole. You see, there's your username, so you don't forget. We had a lot of people complaining that they forgot the username. OK, using Apache Guacamole, you start a virtual machine. And yeah, that's about it. Then you can start programming. This has the entire setup. So what you can see is there's a small UI. But next to that is just a virtual machine. So you can do anything you'd like. You can also see that, well, it describes how it works. You can get a rest. You need to read well. And then you can implement a solution. And we measure a couple of things like coding speed, regression, refactoring, OO, unit tests. So all of these things are measured. So there's some time left. Let's start. You can pick your favorite IDE, as long as your favorite IDE is either IntelliJ or Eclipse. But that's a good thing. Like, we want people to use the tools that they are usually. Why would you write on a whiteboard, on a notepad? Like, in your actual work, you're going to use an IDE. So please use an IDE. And as you can see, it just opens the IDE like normal. And then you can open the project, and you can run some tests. Everything like your normal environment just works. They're just unit tests. And if you run them, you can see that they pass, luckily. And the other one, great. Everything runs. So the environment works. We've tested that. Now we can go back to the actual task that we need to solve. So in this case, we need to correct a logical bug in a find function. So first, we have 5 minutes to read the instruction. We're not going into that. Actually, this is pre-recorded, so I can speed it up. Basically, it's very small, just a couple of classes, and you need to read whatever is in there. You need to find, in this case, a logical bug and fix it. These are real-world examples. This is something you could typically run into when doing actual development work. You go in, the IDE gets updated, your new assignment gets added, and you can go into the code, read, and fix the actual bug. So you can see, currently it's not, the unit tests are failing, and now we need to find the value, blah, 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 skip, skip, skip. And it turns out that in the function, we need to call with k instead of head. Took Bert-Jan a while to find it, but he's not the fastest developer. But we fixed it. Now we can run the unit test. And indeed, we see it is actually compiling, and it works. Great. Then you go back. You press next, and you're done with the first task. There are sometimes 5 or 6 different tasks you need to do. There's also a small summary. You can answer questions about the task you had, and this is mainly all for Gunnar. Gunnar loves data. If he could measure every key press, he would like to. So everything gets recorded, and basically he can put his PhD students to work and use all the data to improve the system. For example, he's currently looking at the whole local history to see what kind of a developer you are. Are you somebody who jumps in, starts coding right away? Or are you somebody that jumps in, starts to read everything, understand everything, and then start typing? Maybe. We don't know yet. That's active research he's currently pursuing. We don't know. Between tasks, you can completely log out, close the browser. Perfect. You can actually go to sleep, next day, log in again, remember that username was important, and the virtual machine is just there like before, and you can just continue where you left off. So for us, this is perfect. We also have a company called CodeNomads. They're also using this platform, and they've got developers all over the world, and it even works great for them. It's not just for the Netherlands. So now you have the second task, and the first task, and the fourth task, and you can see it even has like diagrams that you need to understand. So it is a little bit wider than just programming skill. You also need to be able to read and understand things. But yeah, basically, we can skip over this. Let's speed it up. Or just skip. So there's a question. So the question is, did we make the assignments, or were those predetermined? I think it's about 50-50. We changed some tasks.
Yeah, so the system has like 80 tasks currently. And the nice thing about Krebs is actually that you can create your own tasks. You will talk about grading in a second, because you know, if you put in a task, it needs to be of a certain quality. And also, you need to be able to evaluate the task afterwards. And it's quite crucial that the task is ranked. And
they are all calibrated. So it's very important that all the tasks that are in the system are calibrated. And if we add new tasks, usually you get like 4 old ones and 1 new one. And that way we can calibrate the new tasks that's being continuously evaluated. So we introduce new tasks slowly. and they get ranked, and they get the proper weighing. So that is actually important. So if you're done with all the tasks, basically, we can close the entire thing. Let's make sure we actually did it correctly. Yep. Once you submit and you fill in the final questionnaire, you can go back and you get a preliminary result. And this result basically maps your skill on all the previous people that made the grabs test. You can see here, well, I was kind of shitting on Bert-Jan, but he's actually pretty good. He's better than junior, meteor, and seniors in general. It's also surprising to me that the senior group has about the same skill level as the meteor group. It's even a bit wider, so there's a bigger error margin for seniors than in meteors. Some seniors are better, but there are also worse seniors. And you can see all kinds of data is already being collected, but like I said, these results are still preliminary. And that is because there is a manual grading step in there. So why is this? First, what if we have in some cases we have hidden unit tests which run against your code, they can break. If this breaks, doesn't compile, you get a 0, and that's very harsh. Maybe somebody did it 95% correct, and they made one typo and it fails. You don't want to punish somebody on this, especially not when it comes to jobs. Like, you didn't get the job because of one typo, that's harsh. That's why you should never have completely automated tasks. A different thing is that we also have questions that are very hard to automate. So let's look at one example where we do the manual grading. I'm one of the manual graders for grabs now. So if you have a candidate, this is what I do. I go in, and I can register a certain question. And these questions, they are quantitative. So in this case, the question says, for a certain shape type, is the user using an if statement, a switch statement? Does it switch on an enum or a string? I need to look up in the code. I need to check if this is the actual case. And then I fill in the correct answer. So it's not my opinion if the code is pretty or not. No, these are actual questions that are easy to answer, but we still have a human in the loop to actually do it. I'm working on a proof of concept to pre-fill all the answers by an LLM, because they can do that. Like, I can just give the code to the LLM, the question to the LLM, and it's probably correct in 95% of the times. So I want to pre-fill in these answers and make this manual grading step even faster for the people at Grabs and us. So once we do that, and we also make sure there are no errors in the code, then the company can view the result. And as you can see, this is, I think it's actually all the people in the last year that have been paid to test. You see, like, there's a big spread there. And in this case, Bert-Jan got over a 7. So I would definitely invite him for a second talk and maybe offer him a job. There's the spider diagram. You can see on which areas Bert-Jan needs to improve. So regression and OO, not his strongest thing. You can also see everything in a nice report, PDF, which gets sent to the user as well. And it has everything basically the same as we see before. And for us, this works really well. And it works so well that it got to thinking. Who here is a member of FAANG? Actually, I wanted to change shirt and turn into a FAANG developer, but that kind of messes up the microphone, so I'll just put it here. So now I'm going to talk with my FAANG hat on. Bye. For those who don't know, FAANG is a developer community with over 1,000 members, and they post around 1 or 2 news articles each day. They've got their own podcast, conference information. You can probably read up on JFall if you go there now. Tech questions, and one important thing, they are thinking about certification. They've also noticed people don't seem to like this OCP exam because it measures knowledge. It's not really a good fit. We've seen, like everything you said today, knowledge is not the most important thing. Skill is the most important thing. But that's hard to grasp. So somebody wrote this article, it's him actually, about maybe we can use this new tool that we now use at OpenValue with these grabs to measure skill. What if we can do this from Fuji? So there was a meeting with a lot of Java champions, 80+ prominent community members, and they defined what should be tested and how. And they looked at grabs as an example. So wouldn't it be cool if we have like a universal test that you can do, and it says you are now a Fuji senior developer. Or maybe you are a Fuji junior developer, and 2-3 years down the line, you want to take the test again to prove that you are now a meteor or a senior developer. And that's the whole idea that we want to do with Fuji, and that's basically the reason that we are here. Recently, a couple of weeks ago, there was a different blog post by Jan Hendrik, which we know very well, and they've now started a committee, the Fuji Certification Committee, and basically your question as well, how do you get good tasks? And also, how do we keep these tasks private? Because if they leak, well, the certification itself, pretty useless. So their idea is to let everybody have ideas. Everybody here can come up with a task and submit it for public review. Once there is a community review, it gets the green light, it gets passed to the Fuji Certification Review Committee. This is a private group, and they have access to this private GitHub repo that has the actual tasks. And they will change the tasks when they come in so that you can't just collect everything. They will be different in the actual exam, but they will have the same idea. And we want to make maybe 100, maybe 200 different tasks. And we are actually looking for developers that want to try this out, do some self-evaluation. So give yourself a meteor, senior, or a junior label. And that way, we can calibrate these tasks. Because wouldn't it be perfect if we can just have a skill-based certification instead of knowledge-based? Sure, there's always room for knowledge. Knowledge is also important, but it's not the most important thing. The most important thing is being able to use this language that we speak, not knowing every punt and comma. So, probably a lot of questions, but let's do the recap first. What have we learned? Coding is mostly about skill. Knowledge is important, but skill is something different. And research shows how we can measure skill, and we actually found a platform that does this really well. And we want to base a certification on this from Fuji. Questions?
How do you, or would you use this approach with the existing employees, where you don't have the benefit of secrecy?
Well, maybe I can say something about it.
Can we repeat the question?
Sure. Could you use this also with your existing employees, and how do you address the privacy element of this? So, yeah, if you have, so if you do the test, you can determine as a test taker if you want to share the result or not. So that, but of course, if you're not going to share it, and your employer says you should do the test, maybe a little bit tricky there, but at least I would say in those kinds of situations where HR is making you do a test, I mean this happens in all large companies from time to time, I would expect HR to handle it in a confidential way, but there's no other real way around it otherwise, I think, if they want to use it for those reasons. I think the nice thing here about grabs is, because you can you do multiple task sets, you can redo a test at any moment with different tasks, and you can compare the outcomes, so you can track progress.
That's the most important thing. Like, because all these questions have been calibrated, the number that comes out actually reflects your skill level, and you can compare it. So when you hire people, a lot of it is subjective. Maybe you had a bad day, and you rate somebody like, no, he or she is not very good. But that's based on nothing. You'd like to have like a number. So we've done the test. It's a 6. So there has to be a team for him or her because it's just a good developer.
You know, we worked with one client where we did a customized training program, and we had a few students of the program that had like a few years of experience already. They did the test at the beginning, they got a certain score, and after half a year, they got different training programs, and they redid the test with different tasks, and indeed their score went up. So this is a nice thing about yeah, luckily for us,
God, yeah.
for them, for everybody, for sure. Other questions? Please?
How will you prevent, I mean, if you do a test, people will train for the test, no matter what. You measure something. So, yeah.
So the question is, if you're going to do any test and you train for it, you can kind of manipulate maybe the outcome because you trained really hard, right? Is that?
If you measure something, you will start working towards that measurement.
Sure. If you define any KPI, people will tend to behave to let the KPI be in their favor. And I think that's true, but
that's why we want to keep these tasks as close to real programming as possible. So all these tasks have something like, we've got a unit test which fails, and there's a bug somewhere. Can you find it? We have this class. Can you refactor it to make it more readable or better? We have this class, but there's no unit test. Can you implement these 5 unit test methods? So these things are, I don't mind if people train for that, because that will make them better developers.
I think the key thing, like you said, what is being measured is actual coding skills according to what the right type of skills are, based on all those research background things we spoke about. So surely if you train to be a better programmer and you have a higher score, that's the idea, then that's fine, because apparently you increase your skill level by doing that. That's the idea.
Are there other questions? Otherwise,
yeah, I see
yeah, one over there. Yeah, you need to shout. Yeah. No, exactly. So all the tasks that are put initially into the system, they get calibrated, either by people who already took the test previously. They take the test again with new questions, and we know the skill level of somebody. We can also have some tests or some tasks that we already tested, add in 1 or 2 new tasks and see how they score on the ones we know. And we can kind of guess, well, probably their skill level is right here, so this task, and so there's correlation there. Gunnar is using all this data from all the tests and self-evaluation by peers. So what do peers call you as a developer? Are you a meteor, a senior, a junior? All this data gets collected, and he continuously calibrates all these tasks. So the more data we have, the better it gets. And that's also for Fujie why we are looking for beta testers who want to take this test. Yeah. If you're interested, send me an email, send Roy an email.
Definitely.
And you can take the test and you can say, well, I'm a senior developer, or my peers think that I'm a senior developer. You take the test, you do some tasks, and then you get put into the calibration as well. So that's very important to us as well. And there's also this feedback. Did you like the question? Did you find it hard? All this data is collected by Gunnar, and he, like I said, he wants all the data. And he's using that to make the best system possible.
So if you want to do a test drive, let us know. And also, with the Fujie committee, we had quite a few committee members here in the room. Jaco's there, you were with the discussions. So we asked everybody, what do you think the right kind of tasks are? And I think that's basically the best way to go around it. Ask a lot of people who are, well, already have a certain position in the field, ask them about what good tasks are, and crowdsource that, test that, calibrate it against the existing tasks, and then you hopefully get the best types of tasks in the system. It's, I think, the most practical way to go about it. I think it's about time, maybe. Yeah, one more.
So the question is, if you're maybe dyslexic or have problems with understanding text, is there like, what can you do in that situation? The thing is that most of the tasks, they're based around running unit tests and examples. So all the tasks have some examples. They've got some unit tests that are either missing or that you need to implement. As long as you speak Java or Kotlin, by the way, both are supported, you should be fine. It helps if you have like an attention span and actually read the text. I don't do that. Like, that's not the way I work. I just jump in the code, start playing around until it works. And that works as well. So that's one of the things I said before. Like, we are using all this data to find out if there are maybe multiple types of developers. What works best? Maybe we can actually provide advice. It's better if you take time and read the actual assignment. We don't know yet. Like, that's ongoing research for Gunnar. So I'm very interested in the results.
We're 5 minutes over time, I just noticed. So thank you very much. We're here for more questions. Happy to answer them and discuss this. Thank you very much for your attention.